Lesson 1. Position and Motion. Reading Guide. Key Concepts. How does the description of an object's position depend on a reference point? How can you describe the position of an object in 2 dimensions? What is the difference between distance and displacement? Vocabulary. Reference point. Position. Motion. Displacement. Inquiry. Where are you? A short time ago, people on this ship probably saw only an open ocean. They knew where they were only by looking at instruments on the ship. But the situation has changed. How can the lighthouse help the ship's crew guide the ship safely to shore? Describing position. How would you describe where you are right now? You might say you are sitting 1 meter to the left of your friend. Perhaps you would explain that you are at home, which is 2 houses north of your school. You might instead say that your house is 10 blocks east of the center of town, or even 150 million kilometers from the sun. What do all these descriptions have in common? Each description states your location relative to a certain point. A reference point is the starting point you choose to describe the location or position of an object. The reference points in the first paragraph are your friend, your school, the center of town, and the sun. Each description of your location also includes your distance and direction from the reference point. Describing your location in this way defines your position. A position is an object's distance and direction from a reference point. A complete description of your position includes a distance, a direction, and a reference point. Reading check. What are 2 ways you could describe your position right now? Using a reference point to describe position. Why do you need a reference point to describe position? Suppose you are planning a family picnic. You want your cousin to arrive at the park early to save your favorite picnic table. The park is shown in Figure 1. How would you describe the position of your favorite table to your cousin? First, choose a reference point that a person can easily find. In this park, the statue is a good choice. Next, describe the direction that the table is from the reference point, toward the slide. Finally, say how far the table is from the statue. About 10 meters. You would tell your cousin that the position of the table is about 10 meters from the statue, toward the slide. Reading check. How could you describe the position of a different table using the statue as a reference point? Changing the reference point. The description of an object's position depends on the reference point. Suppose you choose the drinking fountain in Figure 1 as a reference point instead of the statue. You could say that the direction of the table is toward the dead tree. Now the distance is measured from the drinking fountain to the table. You could tell your cousin that the table is about 12 meters from the drinking fountain toward the dead tree. The description of the table's position changed because the reference point is different. Its actual position did not change at all. Key concept check. How does the description of an object's position depend on a reference point? The reference direction. When you describe an object's position, you compare its location to a reference direction. In Figure 1, the reference direction for the first reference point is toward the slide. Sometimes the word positive and negative are used to describe direction. The reference direction is the positive plus sign direction. The opposite direction is the negative sign direction. Suppose you specify east as the reference direction in Figure 2. You could say the museum's entrance is positive 80 meters from the bus stop. The library's entrance is negative 40 meters from the bus stop. To a friend, you would probably just say the museum is 2 buildings east of the bus stop and the library is the building west of the bus stop. Sometimes, however, using the words positive and negative to describe direction is useful for explaining changes in an object's position. Describing position in 2 dimensions. You were able to describe the position of the picnic table in the park in 1 dimension. Your cousin had to walk in only one direction to reach the table. But sometimes you need to describe an object's position using more than one reference direction. The city shown in Figure 3 is an example. To describe the position of a house in a city might require 2 reference directions. When you describe a position using 2 directions, you are using 2 dimensions. Reference directions in 2 dimensions. To describe a position on the map in Figure 3, you might choose north and east or south and west as reference directions. Sometimes north, south, east, and west are not the most useful reference directions. If you are playing checkers and want to describe the position of a certain checker, you might use right and forward as reference directions. If you are describing the position of a certain window on a skyscraper, you might choose left and up as reference directions. Reading check. What are 2 other reference directions you might use to describe the position of a building in a city? Locating a position in 2 dimensions. Finding a position in 2 dimensions is similar to finding a position in 1 dimension. First, choose a reference point. To locate your classmate's home on the map in Figure 3, you could use your home as a reference point. Next, specify reference directions, north and east. Then, determine the distance along each reference direction. In the figure, your classmate's house is 1 block north and 2 blocks east of your house. Key concept check. How can you describe the position of an object in 2 dimensions? Describing changes in position. Sometimes you need to describe how an object's position changes. You can tell that the boat in Figure 4 moved because its position changed relative or compared to the buoy. Motion is the process of changing position. Motion relative to a reference point. Is the man in the boat in Figure 4 in motion? Suppose the fishing pole is the reference point. Because the positions of the man and the pole do not change relative to each other, the man does not move relative to the pole. Now suppose the buoy is the reference point. Because the man's distance from the buoy changes, he is in motion relative to the buoy. Distance and displacement. Suppose a baseball player runs the bases, as shown in Figure 5. Distance is the length of the path the player runs, as shown by the red arrows. Displacement is the difference between the initial, first, position and the final position of an object. It is shown in the figure by the blue arrows. Notice that distance and displacement are equal only if the motion is in one direction. Key concept check. What is the difference between distance and displacement? Distance and displacement. When a player runs to first base, the distance is 90 feet, and the displacement is 90 feet toward first base. When a player runs to second base, the distance is 180 feet, but the displacement is 127 feet toward second base. When a player runs to home base, the distance is 360 feet, but the displacement is 0 feet.